Hello and welcome to the Binomial Theorem, Part 1. I'm going to start off by showing you, first of all, what we mean by a binomial. A binomial is when you have two things added together, so like A plus B, or maybe 2x minus 3y, anything like that, that's a binomial, or maybe it's just x plus 5, etc. Okay? What we're going to do is we're going to look at these binomials when we take them and raise them to various exponential powers. So we're going to start off with x plus y and raise that to a 0. Okay. Now if you do that, it's just a 1. Okay. Anything raised to the 0 is just 1. Now what if I take this binomial and now I raise it to a 1? Okay. So I raise it to a 1, well, I'm going to have 1x plus 1y. Okay, in other words, just the stuff itself, the base itself. Then let's take a look and let's bump it up till it is squared. Now, I won't expand it all out. I know you guys know how to do this. What you end up with is you would have an x squared, then you'd have 2 of these xy's, and then you'd end up with a y squared. All right. Now, there's one more that I like to, but then that's the end of it, because these really start to become a lot of work. So, cubed. Now, if you were going to cube this, it would be busy enough as it is. Just to make sure we're clear on that, let me show you how I would do it. I would take x plus y and multiply it, whoops, let's get rid of that equals, and multiply it by the x plus y squared. So this is going to give me the one I already know, which is x plus y squared. And if I expand this all out, then I'm going to develop x plus y, the expansion of x plus y cubed. So what would I get? I get an x plus an x squared, so x cubed, then an x plus a 2xy, which would be 2x squared y, and then an x times the y squared. Okay, then I'd have the y times the x squared, then a y times the 2xy, so 2xy squared, and then the y times the y squared. So now let's see what that looks like. There's an x cubed, then there is 2x squared y, and I think that's it for x squared y. So there's 2x squared y's. Okay, wait a minute. Nope, we missed one. Sorry, here it is. There's an x squared y right here with these 2x squared y. So actually, sorry, that's a 3. Good thing I checked my notes. Okay, then we have an xy squared and 2xy squared. So there's 3 of those as well. Xy squared. And then we have the 1x cubed at, y cubed at the end. All right, there it is, all expanded out. Now, you'll notice I left a little room here. And you also notice how much work this was and how many mistakes you can make, as I demonstrated there. Boy, it gets messy. You can imagine if this was x plus y to the 4th or the 5th or the 10th. It'd be a crazy amount of work. So I'm going to show you some pattern stuff, and I think you're going to find that that makes it a lot easier. First of all, let's look at the coefficients of all of these terms. I have a 1. Then I have a 1 and a 1. So I have a 1 and a 1 there, yeah. Then I have a 1, 2, and a 1. This is looking kind of familiar. But anyway, then I have a 1, a 3, and a 1. So a 1, whoops, it's a little out of place. A 1, 3, 3, and we'll just squeeze it in here, and a 1. Okay, obviously the coefficients follow Pascal's triangle. So that's a real advantage. So really is, if we know Pascal's triangle, we know on the next level what all the coefficients would be. You know, we know if it was x plus y to the fourth, I should be seeing 1x something. Then I should see a 4, a 6, and a 4, and then a 1 at the end. Okay, so that's part of the story. The other thing to look at is how the x's and the y's behave. Okay, the first part doesn't really show it, but let's show this one here. It's x plus y squared, and then we start off with x squared. This is x plus y cubed, and we start off with x cubed. Okay, so whatever this exponent here is, if it's x plus y squared, you're going to start off, you're going to have x squared. Then you'll notice x drops by 1, so it's x to the 1, and then x disappears. In here, you see how it's x cubed, then x squared, then x to the 1, and then x disappears. And the y's are doing the same thing, but in reverse order. See, like here, you got your y squared at the end, then y to the 1, and then the y disappears. Same thing here, y cubed, y squared, y to the 1, and then the y disappears. So, what does that do for us? Well, it gives us a way to predict. So let me show you, let's say I was going to do the next row, okay? So the next row looks like this. I've got x plus y to the fourth, but I don't want to expand it all out. So first of all, I sort of erased them, but we know what the coefficients are. There would be a 1, then we know the next term would be a 4, then there was a 6, then a 4, and then a 1. Okay, so that's our coefficients. The next thing I do is I look at, well, what's the first part of my binomial? It's x. So this would be x to the 4, then it would be x cubed, then it would be x squared, then x to the 1, and then it disappears. Okay? Now the next part of this is positive y. So now let's build that, but in reverse order. So I'd have y to the 4 at the end, then a y cubed, then a y squared, then a y to the 1, and then it disappears. Well, the only other thing to consider is that this is positive stuff, so there's not going to be any sign changes in here. So you know what? We just did it. We did the expansion using what they call the binomial theorem. This kind of analysis is what is called the binomial theorem. So that takes care of that. And, you know, we'd clean up. We'd probably drop these 1s here. Oh, there's one more little trick to show you. Notice that if you take your two parts of your binomial, the x and the y, look at your exponents. You have 3 and 1, adds up to 4. 2 and 2 adds up to 4. 1 and 3 adds up to 4, and then there's the 4. So you'll notice that your total degree for all of your terms is always the same as whatever the exponent is in the original binomial. Okay, so now I'm going to do a longer example. Let's check the clock here and see where, oh, we better shut down and do that one separate. So we'll do that one next.